Okay, everybody, so today we're going to talk about right triangle trigonometry. The beautiful thing about this is I hopefully can show you some concepts you learned in geometry and help you see the connection it has with the trig unit we've been working on, okay? So we're going to understand special right triangles. They are 30, 60, 90, and 45, 45, 90. And then we'll connect that to the unit circle, okay? And then we'll review some real world problems. So in geometry, you learned about two special right triangles. They are considered special because there are simple relationships between the sides that are worth knowing. So today we'll see how these triangles can help us make connections between the unit circle and right triangle trig, okay? So the first thing I want you to do is there are 3 45, 45, 90 triangles shown below, okay? Everybody see those 3 triangles? What relationship do you notice between the side lengths? So nobody say anything. Everybody take a few minutes, look at each triangle, and see if you can figure out a relationship between the side lengths. Okay? Do what? No, not yet. You can tell me in just a second. What do you notice? You can tell me if you want. You said the adjacent.
I mean, not the adjacent and the opposite.
And the opposite have a square root of 2. Okay.
Can you say something about the angles too?
You can. So you'd have to pick just one of the 45s to label. Otherwise, you have 2 adjacents and 2 opposites, right? And if these are both 45 and 45, then that last one is 90. Because triangles, in Euclidean geometry, triangles always add up to equal what? 180. You're probably sitting there going, every triangle does. Actually, in grad school, I took a class called non-Euclidean geometry. It was on a sphere. And when you draw triangles on a sphere, they can add up to more than 180. It'll blow your mind if you do it. It was crazy. I loved it. Because we actually had a sphere that we could draw on it. So, because I'm a visual learner, right? So, anywho, the beautiful thing for y'all is they always add up to 180. So, 45 plus 45 is 90. 180 minus 90 is 90. Okay? So, yes, if I pick one of these, I'm just going to grab this top one. The side across from it is always opposite. The side across from the 90 is always hypotenuse. So that would mean this would be adjacent. So his observation is that opposite and adjacent have that square root of 2. Is that the case if I look at this one? Let's see. Okay. And then this one. So, do you agree with his observation? Yes? Okay.
They're equal to each other.
Do what?
They're equal to each other.
They're equal to each other. Okay. What's equal to each other? Keep talking to me.
Adjacent and opposite.
Adjacent and opposite are equal to one another. Why do you think that is? Remember what I told you. So you should have learned in geometry that the smallest angle is across from the smallest side. The largest angle is across from the largest side. Remember that? Right? So if they're both across from 45s, then they're going to be equal. Okay? So these are called special. They're isosceles right triangles. You remember that word isosceles? Isosceles means 2 of the legs are congruent. So these are isosceles right triangles. Okay? Any other observations? What? The hypotenuse times the square root of 2 over 2 is equal to what?
Equal
So either opposite or adjacent?
Yeah.
Okay, I'm just going to write opposite. Are you okay with it? So let's see. If this one's hypotenuse is 1, then that would be 1 times square root of 2 over 2. And that equals opposite. Does that work for that one? Yes? Okay, let's look at this one. If it's this one, that would be opposite of 6. 6 times square root of 2 over 2 is supposed to equal 3 times the square root of 2. Does it? Yeah? So is his observation correct? Yes? Okay, let me ask you a question. If you wanted to solve this, good job, by the way, all of you. All of those observations are good. It's not that anybody's is better than anyone else's, okay? Good job. So if I said, please solve this for hypotenuse. Please solve this for hypotenuse. What would you do? You'd have opposite divided by square root of 2 over 2. Okay. So this will be hypotenuse. Okay. So hypotenuse equals, this would be opposite, keep, change, flip. So you keep opposite, you change it to multiplication, you'd be multiplying by 2 over the square root of 2. So then that would be what? That would be 2 times the opposite, right? All over square root of 2. Yes? And then for some strange reason, whenever we have formulas in here, we don't like radicals in the denominator. So if you had to rationalize that, what would you do? You would multiply by the square root of 2 over the square root of 2, right? So this would become what? That would become what? 2 times square root of 2 times opposite, yeah? All over what? All over 2, because the square root of 2 times the square root of 2 is 2. Can you simplify? Yes. Very good. You just derived the formula. It's leg times the square root of 2, or square root of 2 times opposite. Every 45, 45, 90 triangle has that formula. When I taught geometry, I didn't derive it this way, okay? But I think it's more important when you can make observations yourself, okay? So I just told students it's always leg times square root of 2. I called it a leg. What did we just say about these two legs? Those two legs are equal, congruent. So that was the one formula I said for them to memorize. It's called leg times square root of 2. And that will always give you the length of hypotenuse, okay? And you just derived it, which is pretty cool. Okay, so show how you can use any of the above triangles to find sine of 45 and cosine of 45. Which one do you think is the most obvious? Think about the unit circle and find sine of 45 and cosine of 45. So if I draw my unit circle like this, and this is 45 degrees, and I drop that straight down, right? What's the length to get out to this unit circle? What is the length? What's this side called? This side is special. It's called the hypotenuse, okay? Because we drop it straight down, yeah? But look, if I draw a circle, if I connect this and draw a circle like that, okay, pretend that's perfectly centered. Sorry, it's not, but pretend it is. That side I highlighted is special on a circle because it's called something. It's called the what of the circle? The radius. Anytime you connect the center to the circle, it's called the radius, right? So what do you notice about this oh, okay. Well, that's good because I can make it a little better. What do you call that side? I mean, how long is that radius if we're on the unit circle? Good grief, come on. You're on the unit circle, y'all. Say it louder. 1. This is a 1 because we're on the unit circle. So what did you just discover if that's a 1? I said that the two side lengths, hypotenuse equals what for 45, 45, 90? Leg times the square root of 2. How many of your angles are the same? 2. So that's how I remember it's times square root of 2, okay? So if you know the hypotenuse is 1 and you're trying to find this leg and this leg, what would you do to solve that? Divide by the square root of 2. Good. So 1 over square root of 2. Does that look like any of your special families? Yes, just kind of in disguise, right? Which family is that? Pi over what? 4. Pi over 4. Didn't I cut this in 4? If I draw another one up there. So this is actually the pi over 4 family, the 45-degree angle is. So the cosine of 45 degrees is what? Square root of 2 over 2. And the sine is? What's sine of 45 degrees? Square root of 2 over 2. Pretty cool, yeah? That's why I like math, because it doesn't matter if you have just some arbitrary triangle out here, then you put it on the unit circle, and you can still get those same things, as long as on the unit circle you have a radius of 1, okay? Now, that would not have worked if your hypotenuse was a different length, okay? So, we will have some triangles where that's different. So, in which of the triangles up there was that relationship most obvious? The third one, yeah, because you could see that, right? So the third triangle, you can abbreviate a triangle by just making the triangle symbol. It's kind of amazing. So the third triangle, because the hypotenuse was 1, the hypotenuse is 1, and each leg was? Look at the legs on that third triangle. Square root of 2 over 2. Yeah. You do realize on the unit circle why the coordinates are what they are. Because you go right that many. Let me highlight so you can see what I'm saying. You go right and up. So that's why you get these coordinates right here of square root of 2 over 2, comma, square root of 2 over 2. Because you go right and up. Does that make sense? Okay, here's another special right triangle. It's a 30, 60, 90. So take a few minutes. If that's 30 plus 60, that's 90. 180 minus 90 is 90. Okay? So each of these also have a 90. Now, can I just call them leg? Are the two legs equal?
No.
No, they're across from a 30 and a 60. Do you see that? The side across from the 30 is going to be the smallest. The side across from the 90 is always the biggest. So I actually call these short leg and long leg. Do you understand why I'm saying that? So across from the 30 is going to be which one? Short leg or long legs? Short leg. Across from the 90 is always called hypotenuse. So the one across from the 60 we're going to call long leg. So let me write up here what those mean. SL stands for short leg. LL stands for long leg. The reason why I'm writing those is because I want you to start to try to identify a relationship for that triangle. Just look at it, okay? Is it multiplied by 2? I'm going to show you a little differently on this one. Do you remember sine of an angle? If you know the angle, or if you're trying to find the angle, SOHCAHTOA, right? Do you remember that? SOHCAHTOA. So what is SOHCAHTOA? SOHCAHTOA, right? So you pick an angle then. So pick one of those triangles. You want to use the 8, the 4, and the 4 times square root of 3, the 1/2, the 1, and the square root of 3 over 2. or the 3, the 6, and oops, that should have been on the outside. I'm sorry. This side is right here, y'all. It should have been on the outside. I apologize. I didn't catch that before I printed it. Or 3 times square root of 3. Which one do you want to use? The first, the middle, or the last? The last one? Okay. So you have a 3, a 6, and a 3 times the square root of 3. Find the sign. Sign is opposite. So you're probably going, well, which side is opposite? You choose one of the angles, either the 30 or the 60, and then you label accordingly, okay? So do you want to use the 30 or the 60? 30. Okay, thank you. I'm going to grab that angle. The side across from it is called opposite. Don't worry, I'll show you the short leg, long leg in just a second. Okay, across from the 90 is what? Hypotenuse. So this last side is adjacent. Okay, so stands for sine of the angle. Sine of the angle. So sine of 30 is opposite. So what's opposite? 3 over, what's H stand for? Hypotenuse, which is 6. What is 3 over 6? 1/2. So the sine of 30 degrees is actually equal to 1/2. Would that be the same if you use the middle one? The sine of 30 degrees. So if I grab the 30 and go across from it, that would be opposite. This would be hypotenuse. So this side would be adjacent, yeah? What would you get if you did opposite divided by hypotenuse on that middle one? You'd have 1/2 divided by 1, which is just 1/2. So you see, it doesn't matter which triangle you pick. If you're using the 30 degrees, you can get it, okay? All right, what would cosine be then? Cosine of 30 degrees. We're using that last triangle. So it's what Maggie chose. I love it. So what's adjacent? Look at your last triangle. What's adjacent? 3 square root of 3 divided by, what's the H stand for? Hypotenuse, which is 6. 3 square root of 3 divided by 6. Can you reduce? Yes. 3 over 6 is actually 1 over 2. So 1 times square root of 3 is just square root of 3 over 2. So Maggie, it says, which triangle did you choose and why? Why did we choose the third one, Maggie? You feel like it was easier to see with those numbers, the 3 and the 6? That's fine. Write that down. Okay, it says now find sine of 60 and cosine of 60, and what patterns do you notice? So you want to pick a different triangle for the 60 because we labeled the last and the middle. You want to use the first one? Okay, so on the first one, I'm going to pick which angle? I'm finding sine of 60, so I'm going to use 60. So across from 60 instead of long leg, don't worry, I'll come back to that. I'm going to actually call it opposite. Across from 90 is still going to be hypotenuse. So this other leg right here, we're going to call it adjacent, right? I'm on this first triangle, everybody. Opposite of 60 because I'm looking for sine of 60, okay? How do we find sine? So, ka, and then toa. I'm not writing it, but so, ka, toa, right? So sine is what? Sine of the angle equals opposite 4 square root of 3 divided by, what's the H? Hypotenuse, which is 8. Can you reduce that? Yeah. 4 over 8 is 1/2. So we get 1 times square root of 3, which is square root of 3, and over 2. Okay? Cosine is adjacent, which is what? I'm sorry? 4 over 8. 4 over 8 is 1/2. What patterns do you notice? What patterns do you notice? It's just flipped. Yeah, the cosine of 30 became the sine of 60, and the cosine of 60 is the sine of 30. Does everybody see that? Okay, so that's a pattern she notices. Do what? The pi families. Okay, so 30 degrees is which family? It has square root of 3 over 2 is your cosine, and 1/2 is your sine. Everybody remember, 30 degrees was this tiny sliver right here. Y'all remember that? Which family goes up to 30 degrees? Which family is that? Pi over 6. So is it shocking that we got those same values, square root of 3 over 2 and 1/2? No. So that means we go over square root of 3 over 2 and then up 1/2. That makes sense, yeah? It's tiny. Okay? And then sine of 60, which family is that? If we rotate up 60 degrees, which was our biggest family, wasn't it? Because we had 30, 45, then 60. And then you drop down, straight down. Which family is that? Pi over 3. So, are you going to have new values to memorize? No. I'm trying to help you because in calculus, for those of you who take calculus, she does work with degrees quite a bit. So, if you can remember, 30 is just pi over 6, okay? And then 45 is just pi over 4. 60 is just pi over 3, okay? All right, so remember, if we have circles with a radius of 1 and they're centered at the origin, they're called unit circles. So label the 3 side lengths of the triangle and then find the x and y coordinate on the point. So if this is 30 and we drop it straight down to the x-axis, that's 90, right? We just discovered, oh, and I forgot to tell you your formulas. Let me help you. These are 2 formulas, okay? Here's the first formula, which y'all derived. It was way over here. Let me highlight it for you. It's just square root of 2 times leg. That's how I remember it. So the hypotenuse is just leg times square root of 2. And remember, 2 of the angles are the same. That's an abbreviation for angle. If y'all had me for geometry, you would get used to that. That means angle, okay? So 2 of the angles are the same. You're going to multiply the leg times square root of 2, and that will give you the length of the hypotenuse, okay? All right, so for this 30, 60, 90 triangle, I'll write it down here, and then we'll go up there and look. The hypotenuse is equal to short leg times... Let me go up here and actually look. What's the hypotenuse equal? Short leg times what? Look. The hypotenuse is equal to the short leg times what? 2. Good. You just found the formula. The hypotenuse is equal to the short leg times 2. Okay? The long leg, this is across from the 60, everybody. The long leg is equal to the short leg times what? Let's look. How would you find the long leg using the short leg? It's just times square root of 3. There you go. There's your 2 formulas. They will always work. You just have to remember, short leg is across from 30, long leg is across from 60. Okay? You can get these without it, but if you can remember the formulas, it just makes your life a lot quicker, right? But you can always do SOHCAHTOA, and then you just have to figure out which answer would help. All right, so we remember 30 degrees, the radius is 1, right? And we go over how much versus up how much? We go y'all, it's literally right on the paper beside you. If this is 30 degrees, cosine is over and then up, right? So cosine of 30 was what? Square root of 3 over 2. Thank you. And then you went up how much? You went up 1/2. Good. I just said the 30 was the pi over 6 family. Yeah? Okay. Don't make it harder than it is, okay? So it says find the x and the y coordinate of the point on the circle. We did that. So look at this one. 45. If this is 45, 45, 90. What was this one? Square root of 2 over 2. Square root of 2 over 2. Good. Nicely done. That's it. And lastly, the 60. 1/2 square root of 3 over 2. Thank you, ma'am. Questions? Is it kind of cool to see it on the unit circle? Let me ask you a question. If you had to draw a 60-degree triangle in the one beside it, would you connect to this first line? Is that 60 degrees? No, this goes back to reference numbers, okay? Reference numbers are always measured the shortest distance to the x-axis. So that's actually 30 degrees, right? This would be 45 degrees. So you'd actually have to go all the way up here to get that reference angle of 60 degrees, okay? So keep that in mind. It's always the shortest distance to the x-axis, okay? All right, so find the tangent of 60. All right, so the cosine of 60 is what? The cosine of 60 degrees is what, y'all? 1/2. Good. So we all remember, because it's been a while since y'all did this, that cosine is the x-coordinate, right? It's adjacent over hypotenuse, or it's the x-coordinate, okay? So then sine is the y. So sine of 60 is what? Square root of 3 over 2. So what is the tangent of 60? Remember, you get a tan in South Carolina. So sine over cosine. So what's the sine of 60? Square root of 3 over 2. Didn't we just write it? And then divided by the cosine of 60, which is 1/2. Keep, change, flip. Square root of 3 over 2 times 2 over 1. Won't those just simplify? And you get square root of 3. So don't forget all that stuff before the break, okay? All that trig. Questions for me? Yes, ma'am. Sure, thank you for asking. All right, so let's review. I'm just going to let you label really quickly. I wanted you to have a visual of all those 30 degrees in there, okay? So go ahead and label for yourself right here, just to help you review your special angles. And then you'll do it again for the 45, 45, 90, and then for the 60 degree. Okay? Take a few moments to do that. All right, the first one, 30 degrees. Which family is that? Pi over what? 6. Okay, so remember that's square root of 3 over 2 and 1/2. So if you're in the second quadrant, that's going to be what? Do you need to memorize all these values? No, you just what?
The sign.
Just change the sign. So in the second quadrant, it's negative square root of 3 over 2, but still positive 1/2. And then down here, negative, negative, right? And over here, cosine is positive, but sine is negative. Okay? Remember, All-Star Trig class. That was that quick reminder, okay? How about 45, 45, 90? What family is that? Pi over 4, because you're cutting that 90 degree in half, okay? So that is square root of 2 over 2, square root of 2 over 2. And then you can negate as you go around. So negative square root of 2 over 2, positive root 2 over 2. Down here it's negative, negative. And then over here it's positive, negative. So next year, she's going to really emphasize finding that reference number, that shortest distance, and quickly give her that value, okay? So you probably want to keep these notes. Hopefully they'll be helpful to you, okay? All right, and then the 60 degree. 60 degree is which family? Pi over 3. Good. Which we know is 1/2 and square root of 3 over 2, right? So then over here, we're going to negate the x. Down here, we're going to negate both. And over here, we're going to have positive because we went right, then down. So it's positive 1/2, negative square root of 3 over 2. Questions? So you're probably going, why are we spending an entire day on this stuff? Well, we're not, but I want you to see the connection before I move on to other triangles. So do you have any questions for me about when the hypotenuse has a length of 1? No? Okay. All right, so it says, given alpha is 30 degrees and BC equals 8. Now, where is BC? Where is BC? Yes, it's this length right here. Okay, this is an 8. All right? It says find any missing angles or sides. So it says alpha is 30. I like to write it in there. Well, if alpha is 30, then you're missing beta. What is beta? 60. Okay? So this is obviously not a special on the unit circle, right? It's not a special right triangle on the unit circle. Because if that's an 8, is there any way the hypotenuse is going to be a 1? No. So that's where you need to remember your formulas, okay? So let's write them. Is this the one that has the square root of 2? Or is this the one that has that square root of 3? Square root of 3. I want you to notice something. 3, 6, 9. That will help you. 3, 6, 9 goes with the square root of 3. Versus the hypotenuse times square root of, the hypotenuse equals leg times square root of 2, where there were 2 angles. This one was those other 2 formulas, which I wrote right here for you, okay? So square root of 3 goes with the 30, 60, 90, okay? All right, so let's rewrite those so you'll learn them. So hypotenuse equals short leg times 2. Long leg equals short leg times square root of what? 3. And how do I remember that? 30, 60, 90. They're all multiples of 3, okay? Versus 45, 45, 90. 2 of them are the same, so you multiply by square root of 2. More Shannon or Cherylisms for you today. You gotta help your brain, right? All right, so we found the missing angle. I'm now going to label the side across from the 30 is short leg. The side across from the 90 is always hypotenuse, so this is going to be across from 60, which we're going to call long leg. So which side is the hypotenuse? That is CA or AC. So AC equals, may God bless you, short leg, which is 8, times 2. So yes, whoever said 16, thank you. AC equals 16. Could you put CA instead of AC? Yes, it doesn't matter. Okay? All right, which side is the long leg? AB or BA? And that equals short leg, which is 8 times square root of 3. And you're done. Pretty quick if you remember the formulas, yeah? Okay. All right. So how can we connect that then to find each of the following? I'm going to bring back that last lesson right here. So sine of alpha plus beta. Sine of alpha plus beta. Okay. I'm going to actually draw another triangle because I've learned from experience that this can sometimes be confusing for some people. If it is not for you, then just sit there and be blessed. Okay? But I'm going to move the beta down to this one so that I can then label that top triangle just using the alpha. Okay? So if alpha is the angle, the side across from it is called opposite. You don't know that it's a special right triangle, so you can't call it leg or short leg or long leg. I wouldn't on this one because it does not look like it has that relationship, right? I don't see my square root of 3s, right? Okay, so that's opposite. The side across from the 90 is always hypotenuse, which means this is adjacent. But on the triangle down here, where I focus on beta, that 8 is actually going to be opposite. Across from the 90 is still hypotenuse, but this side becomes adjacent. You can trust me. I got your back. I know it seems like extra work, but we're doing it for a reason, okay? So watch. Tell me, when it was sine of an angle plus an angle, what was that little chant I told you would help you? Sine. Come on. Yeah, sine, cosine, cosine, sine. And I'm leaving plenty of space for myself. Sine, cosine, cosine, sine. Sine, cosine, cosine, sine. Okay? And remember, when it's sine, you keep the same. So I'm going to put a plus. Okay. Whatever's written first, I'm going to write first. So what am I going to put right there? Alpha. Whatever's second, I'm going to put right here. Okay? So don't worry. Let me move this, actually. Oh, my. I obviously don't know what I'm doing. Hold on, team. Oh, well. I was trying to move this whole thing. There we go. Okay. So this is going to be alpha. This is going to be beta. Can you tell me what the sine of alpha is? So alpha is up here, right? Sine. Sine is equal to what ratio of side lengths? Sine is equal to?
Opposite.
Say it loud and proud, sir. Opposite over hypotenuse. SOHCAHTOA, right? Opposite over hypotenuse. So if I look here, opposite is 15. Hypotenuse is 17. What's the cosine of beta? So which triangle should I look at? The top or the bottom? Bottom. Cosine is adjacent over hypotenuse. Look at what adjacent is on that second triangle. It's 15. Because we're working with a different angle, instead of being opposite, it's now adjacent, okay? All right. Now go back to your top triangle. What's the cosine of alpha? It's A over H. So 8 over 17. And then times sine of beta. Sine is opposite over hypotenuse. So 8 over 17. Okay? Now do you see why I did two different triangles? It could get confusing when you try to label. You'll have one side says opposite, but then if you label, you'll have it is also adjacent, so that can be confusing. Okay? All right, what's 15 times 15? 225. 17 times 17? 289. You all need to learn your perfect squares. I can't stress that enough. All right, plus 8 times 8. 64 over 289. You're adding fractions. They have the same denominator, which is good. So I can do a little scratch work right here. 5 plus 4 is 9. 2 plus 6 is 8. 289. So I get 289 divided by 289, which is 1. So that whole thing became a 1. Pretty cool, yeah? All right, I gave you it split on this one. You'll notice the next one says cosine of 2 alpha. Another way to write that is what? What's another way to write 2 alpha? Say it loud, girlfriend. Alpha plus alpha. Good job. That's helpful because now hopefully your brain says what? Come on, chant it. Come on. Y'all are so nervous. I sing by myself to y'all. And there's 17 of you. There are 17 beautiful voices and none of you will do it. Fine. Cosine, cosine. Sine, sine. Thank you, friend. There it was. Cosine, cosine, sine, sine. Cosine, cosine, sine, sine. Okay? And remember with with cosine, you change. I like to say change because the C with C. You can say switch. It's fine. You're owning your education. All right, so change it to a minus. Then I'm going to put cosine of alpha because that's first, but alpha second. Alpha, alpha. So you remember, what was the other way we could write that formula? If it's cosine of alpha times cosine of alpha, you can write it squared. Yep. Cosine of alpha squared minus sine of alpha. Now, you don't have to do that step, but you can. Okay. So what's the cosine of alpha? Let me slide back up to my top triangle. Alpha cosine is adjacent over hypotenuse, so we're looking at the top triangle. What's adjacent? 8. 8 over 17, but I got to square that. Minus, what's the sine of that triangle? 15 over 17. Okay, 8 times 8. 64. 17 times 17. 289 minus 15 times 15. 22, 25. 289. Remember, very first lesson I told you, if the signs are different, subtract the big number minus the small number and then keep the sign of the bigger number. So 225 is bigger, right? It is minus, so my answer is going to be positive or negative? Negative. Okay, so let's subtract. 5 minus 4 is 1. 2 minus 6, does that work? No, so we borrow from that. This becomes a 12, right? We took 10 of them. 10 plus 2 is 12. 12 minus 6? 6. 1 minus nothing? 1. So negative 161 over 289. See how the last section is helping with today's section? Okay, what's this formula? Good job. Plus or minus square root of 1. And then it's cosine of the angle, right? Over 2. When it was sine, we subtract. When it's sine, you subtract. When it's cosine, you add, right? Now, if you notice on this one, you're probably going, wait a minute, how do I know which quadrant it's in? Well, look at your leg. The legs, they're all what? The legs are both positive, so you're in which quadrant? 1. Good. So if you're starting in quadrant 1, you half it, you're going to end in quadrant 1, and sine is positive. So I'm going to have 1 minus, what was that? The cosine of alpha? 8 over 17 divided by 2. Good. So 1 minus 8 over 17. I'm going to work my scratch work. That's going to be 17 over 17 minus 8 over 17, right? That fancy one. 17 minus 8? 9. So I get 9 over 17, right? So I now have 9 over 17 divided by 2. So I got to keep change flip. So that's 2 over 1, which means 9 over 17 times 1/2. So I'm going to get 9 over what? 34. Does it benefit me to split this one? Yes. Square root of 9 over square root of 34. Square root of 9 is 3. So 3 over the square root of 34. Questions? No? Get a stretch, y'all. We got 11 more minutes. I'm starting to lose some of you. Stretch. Yes, ma'am. Of course you can. Thank you for asking. Come on, team. Stretch. Do something. Wake up. All right, we only have a couple more, and these should be review, hopefully, from geometry, or from what we've been doing this year, right? That is a right triangle. Does everybody notice that? For each of the following, we're going to find the exact value of x. So if that's a right triangle, the side across from the 90, we like to call it hypotenuse. If you know one of the angles, or even if you're trying to find one of the angles, you can label using that angle. So the side across from the angle we call opposite, which means this side down here would be adjacent. What uses opposite, adjacent, and hypotenuse? Say what? Yeah, it's S-O-H. SOHCAHTOA, right? Yeah. SOHCAHTOA. That's right. Good job. This is how I taught it when I taught geometry. I said, which side has nothing on it? Adjacent. There's nothing there, right? Opposite has a 2. Hypotenuse has an X. So adjacent has nothing. So over here where I have the A's, I'm just going to mark them out. So obviously I'm using which one? Sine. Sine of the what? Sine of the angle. There's a reason why I've been saying that to you for weeks now. The sine of the angle. What's the angle? 25 degrees. That's very important because your calculator must be in degree mode. That is super important. You have got to be in degree mode. So there's a beautiful button on your calculator that says mode. You press it, right? And then you go down, arrow over, hit enter when you've highlighted degree, and then you hit second mode, which is quit. So you have got to be in degree mode when you solve these, okay? If you're in radians, you're going to get a totally different answer. I know Miss King talked about that because y'all just did some forensic science stuff where she said make sure you're in degree mode, right? Okay. So back to this, sorry. Sine of 25, because that's the angle, equals O divided by H. What is O on this one? 2 divided by what is hypotenuse? X. So how do you solve this? How do you get the X up out of the denominator? Multiply. So I'm going to multiply this by X. I'm going to multiply this by X. So now I have X times the sine of 25 degrees equals 2. How do I solve that for X? X times the sine of 25 degrees equals 2. Divide by sine of 25 degrees. Divide by sine of 25 degrees. So X equals 2 over the sine of 25. So I don't know about y'all. I start to notice patterns. Whenever I'm dividing by X, they literally just switch places when you solve it. Anybody ever notice that? So I just literally switch them. And the reason is because you do all that math, okay? All right, so what is 2 divided by the sine of 25 degrees? Please type it in for those of you that have your calculators. We're going to round to thousandths. That's an AP thing. If it doesn't tell you what to round to, you just round to thousandths. Okay, it cannot be negative because it's a side length.
What's
Are
wrong
you?
with my calculator?
It's not in degree mode. So hit mode.
I just did it. Why is it making me do it?
You gotta hit enter, arrow down and over, and hit enter. Okay, now do the second mode. And now do it again.
My game.
So 2 divided by Did you get 4 point, hey, tune in. Did you get 4.732? I don't know if you could hear our discussion, but she said, I got a negative, and I responded, you can't. It's the side length of a triangle, so that will clue you in, hopefully, that you have it in radian mode, and it's got to be in degree, okay? All right, next one. How do I label this? It's a right triangle, so I'm going to label it. How? Should I find the missing angle? No, that would be more confusing. Then you'd have which one's opposite, which one's adjacent, right? So across from 90 is always hypotenuse, yep. Across from the angle is always opposite, which means this last side is adjacent. Then I'm going to write so, ka, toa. Which side has nothing on it? Opposite, which means I'm going to get rid of sine and I'm going to get rid of tangent because both of those uses opposite in the ratio, right? Okay. So cosine of what? 22 degrees. Cosine of the angle equals adjacent over hypotenuse. So 15 divided by x. I just showed you the trick where when you multiply then divide, they just switch places. Yeah? Okay. So go ahead. 15 divided by the cosine of 22. We're relying on the people with calculators. Sorry, I forgot to give you a heads up to make sure you brought it and charged it. Sorry. Say it louder, sir. What'd you say?
16.27.
16. Okay. 16 point what, ma'am?
178.
178. Do y'all agree? Yes, you agree? Okay. One more concept. We got 4 more minutes. Look, it says to find the degree. So to find the angle, you just hit second and then whatever trig function it is, and then put in your fracture and fracture. Sorry, she's walking in with her boot. Sorry. I love you. I'm sorry, my brain. Oh, sorry, team. Let me send some oxygen to my brain. Okay, then put in the fraction and hit enter. Okay. So if you look at this one, we're trying to find the angle, right? We're trying to find the missing angle, so we're still going to label. Side across from it is opposite. Side across from the 90 is? Oh my word, I was already writing which one I was finding down there. Hypotenuse, good grief. So this is adjacent. So, ka, toa. Which side has nothing on it? Hypotenuse. So we're going to get rid of which two? Sine and cosine, because they have hypotenuse. So we're going to use tangent of the angle. So x is what I'm trying to find. Equals opposite. So 2 divided by 3. So all you do is hit second in your calculator. So that's inverse tan. If you look at your calculator, you're going to see in blue, right above tangent, it has inverse tangent. Okay? So inverse tangent of 2/3. 33.690.
You want us to still put the 0?
I do. Rounding to thousandths. So yes, you do still put the 0, unless I say otherwise, okay? Thank you, sir. Good question. All right, one more. One more, y'all. One more. I'm going to help because we're running out of time. So grab the angle. Side across from it is opposite. Across from the 90 is Hypotenuse, which means the 6 is adjacent. So, ka, toa. Which side has nothing on it? Hypotenuse. So we're going to get rid of sine and cosine. We're using tangent again. That's just coincidence. It's not always going to be that way. All right, so tangent of the angle equals 8 over 6. So to move that tan, you're going to do inverse tan of 8/6 over 6. I'm so sorry. Say it one more time. 53 point what? 13. It's a 0 again?
Yeah.
Lame. I need to give y'all better numbers. All right. That's it. So if it was cosine of x, you just hit second cosine. If it was sine of x, you'd hit second sine. Okay, everybody? Questions for me? No? Have a good day.